now it's your turn if you want to add
Great.
something else.
Let's get going.
Okay, so have fun and good luck.
Thank you. All right, hi, I'm Mike Zyda, and talk today is why the virtual reality you see now is not the real virtual reality. And well, here's the outline of the talk. I'll give you a brief bio in pictures, a little bit of the history of VR, and what the virtual reality is that we are being sold now, and what VR will become and grow into, and R&D directions as well. So start out, brief bio, and I did it in pictures, so it could all be on one page. We'll start at the top corner here. I was a member of a National Research Council committee that put out a report called Virtual Reality, Scientific and Technological Challenges, and this came out in 1995 from the National Academy of Press, and the goal of this report was to tell the US government what should be funded in terms of virtual reality research and development. And it was a about 550-page report. And the interesting thing is, I recently went back over it to write a special a 25th anniversary article for the MIT Press Journal Presence, and just about all of the research directions that we said they should fund back then are still in need of funding. And so it was interesting to see. I also chaired a National Research Council committee called Modeling and Simulation Linking Entertainment and Defense, which basically told the US Department of Defense that it should stop hiring defense contractors to build simulation systems, and that what it should do is start using game engines and entertainment technologies to build their future modeling and simulation systems. And this came out in 1997, and this actually had a very big impact on the US Department of Defense. It took about a $5 billion investment per year from DoD, from the simulation industry, and invested it into games and game technology. It was actually a big change. And that led directly to the America's Army game. I got to build and operate a hit game from inside of a military university. At the time I built this game, I was the director of the MOVES Institute, the Modeling, Virtual Environments, and Simulation Institute at the Naval Postgraduate School. And I built a game development studio inside of the MOVES Institute. And we built and shipped America's Army 1.0 and America's Army 2.0, 2.2, and 2.4, and made a hit game out of it. Hit game back in when the years when these came out, 2002, 2004, was somewhere on the order of 5 million players at that time. So today, a hit game is a much larger number of players. But this actually got me to USC. I also co-authored a book called Network Virtual Environments, Design Implementation with Sandeep Singhal. Up until about 2 years ago, Sandeep was director for networking for the Windows operating system at Microsoft. We started on this book when he was a student, a long time ago. And he was a student of David Sheraton at Stanford University. David Sheraton's two students founded Google. So he actually is a contemporary of them. He's now at Google. Not surprising. He's one of the most brilliant networking people I know. I was senior editor for the MIT Press Journal Presence for 12 years. This is the 25th anniversary of that journal. And this is where we put archival research on virtual reality and technology and application and all kinds of things. Nat Durlak was the founder of this journal, and he was also the chair of the Virtual Reality Scientific and Technological Challenges Report for the National Research Council. And we worked very hard to make Presence the archival journal for VR. The USC Institute for Creative Technologies, I actually wrote the original operating plan and research agenda that founded USC's institute that focuses on virtual reality technology for the US Army. And I did that as a special project for the chief scientist of the Army back in 1999. I also chaired a study called Design in the New Millennium, which is how NASA should design space systems in the future, and founded the Symposium on Interactive 3D Graphics, which is an ACM conference that runs till today. Actually, they changed our name slightly. I think it's now ACM SIGGRAPH Symposium on Interactive 3D Graphics and Games. I founded the MOVES Institute, the Modeling, Virtual Environments, and Simulation Institute at the Naval Postgraduate School, and grew that from nothing to 71 faculty and staff until I quit to go to USC. And I also founded The GamePipe laboratory at USC at the start of 2005. I founded the computer science games program, and I also founded the joint advanced games class between School of Cinema and Engineering School. That became the core part of the USC games program. So I've done a number of things. So this is only part of my bio, by the way. It's just the virtual reality part of my games part of my bio. All right. So let's talk about virtual reality history, and it's important to, one more thing I should add in bio. I started in computer graphics in 1973. In 1973, I made a computer animated film with a couple other undergraduates that was shown at the very first ACM film computer animation festival. It was the first film festival in computer animation ever. So I've been in graphics a long time. All right, virtual reality. So if you go back to 1968, you'll see something like this from Ivan Sutherland, who talked about a window into a virtual world. And the pictures back then were, 3,000 lines per frame. Before, if you put 3,001 lines on there, it would flicker horribly and look really bad. But it gets a lot of attention because back then it was a pretty cool feat. So you started computer graphics early. A lot of the early stuff was wireframe. About 1994, I was running a project where we were building a virtual environment called NPSNet. And NPSNet in 1994, this is a force feedback pedal device where you can feel all of the ups and downs of moving across terrain. It's kind of like riding a unicycle. And so it's actually a really bad idea to do this because this guy is also wearing a head-mounted display. The head-mounted display is back in 1994, about $6,000 for a 320 by 220 resolution. It's really blurry when you put it on there. But it kind of gives, kind of got everyone excited about, hey, this virtual reality stuff is cool. He's got an instrumented, tracked M16 rubber rifle. And this is actually, and he's also got a full bodysuit on. So the bodysuit is actually made out of potentiometers at the joints. Okay, and so there's these weird metal rods. If he moves too fast, he sticks a metal rod in his ear. So it's this is like a Rube Goldberg project because we started this on Christmas Eve in 1993, in which we had the program committee meet to decide we had to build this and have this demo running by the 14th of February, because we were giving a demo to the Director of Defense Research and Engineering, Anita Jones. And so we put this together quickly. We did not at that time have articulated humans in NPSNet. We got articulated humans up and running, and we made this network so you could play across the internet, all from Christmas Eve to February 14th. This is back when people didn't sleep. And so virtual reality, that work came out in 94, the NRC study came out in 95, and pretty much by 1996, that was like the last dime I saw from the Department of Defense invested into technology for virtual reality. What happened is the Department of Defense said, yep, we invented it, let's move on, and they started just focusing on applications for the warfighter. There was a big request from Congress to have DARPA change from doing basic research to doing only things that were of direct applicability to the warfighter. And what that meant was you had to ship stuff to the war zone wherever we were fighting every 90 days or so, otherwise you wouldn't be funded. So basically, a lot of basic research kind of disappeared. So in 2016, things get very exciting because you have all of a sudden $600 headsets, $700 headsets, instead of $6,000. So it's an order of magnitude cheaper, and these can be bought by just about anybody. So you go off and you see the Oculus system there, and you see those trackers that are still not available from Oculus, but they keep promising they're going to come out. And we've got the HTC Vive, which has really good tracking, and actually is the one I always tell people to go to. You've got the Samsung Gear VR, you have the Sony PlayStation VR, and this is all development people who have these now. There's very few people who have these at home unless they're hobbyists or coders or hackers of some sort. And so 2016 and 2017 are really going to be important years for developers, but the really big commercial market for virtual reality and augmented reality is really going to be maybe 2018, 2019, all right? That's where you're going to make money. So this is, everybody who's jumped into VR right now is going to have to worry about how do they stay afloat financially until 2018, all right? So 2016, 2019, you're going to see Magic Leap maybe finally come out with a product. They're a startup that, if you haven't heard of them, you must not read the internet or pay any attention to tech news. They have $1.4 billion as a startup, very secretive. This is where my son works. He doesn't tell me anything either. And but augmented reality got this big boost by Pokemon Go, right? Pokemon Go is pretty awesome. And John Hanke, who has founded Niantic Labs as part of Google, and also who previously founded Google Earth, is sort of the guy behind this. And and you'll also see, the Microsoft HoloLens there, although there's some issues with the Microsoft HoloLens that we'll talk about a little bit later. So what VR does not do now, and I'm going to kind of cover all of these topics, and let's kind of walk through them. And tracking, and current state of tracking is really important. Tracking means I want to know what are the articulations of my body. I want to know where my hands are. I want to track my head. So there's most of these head-mounted displays have head tracking easily, but do they have things that track hands? Yes, they kind of are getting there. And so let's think about Oculus. Oculus is primarily a sit-down experience. So if you go to Oculus and you see their demos, there's a nice easy chair, you sit in it, and they don't want you to get up and walk around. And their hand tracking is supposedly going to come out this year. It's been demoed a lot, but they're having manufacturing issues putting it out. Samsung, we can track your head. You can hold a game controller, and don't use a Note 7 or as you know, the Edge 7 now is also having exploding battery problems. In the Samsung Gear VR, you don't want a phone to blow up in front of your face here. That's a bad thing. I think it mostly just catches fire. I don't think it really blows up. It kind of like bubbles out. And it sounds great. HTC, you don't want to be in a room with windows or whiteboards or video screens or anything shiny, or people who are wearing anything shiny. And so and I'll say, when you get into an HTC environment and walk around, it's really gorgeous. It really is the best that's out there now that you can buy and start building for. All right, I really like it. The only scary thing about HTC, as it's been the Vive, is HTC has been basically a failing phone company, a failing mobile phone company. And so what's really nice in this last year is they spun the Vive part off into its own separate entity, so that when the phone company finally dies, it hopefully can survive. So some of the tracking that we're missing are fingers, eyes, mouth. Where are these? Because if you're really going to do important stuff in virtual reality, fingers become critical. Eyes, there's some reasons you want to track eyes, and mouth. Where are these things? And so let's start out. I want to show. I hope that this video will play. This is an HTC Vive video. This is a friend of mine. She and I are building a company together, and you notice we have to have a second person there. So when you use the Vive, she has to have a second person who goes around behind her and make sure she doesn't trip over the cable. So there's going to be a big market for hooks that hang into the roof of your living room. All right. And you have to be, you got to make sure, yeah. You also see the sort of white paper that's sticking out from the head-mounted display. By the way, this is a cultural thing. Try and get a Chinese woman to put a head-mounted display on where she doesn't know who's the last person who left their bodily fluids on the head-mounted display. All right, and that becomes a big issue if you're going to try and put this out there. I don't know if many of you ever got to see Disney Quest, which was a virtual reality theme park in Disney World in Orlando. And they had a guy there to give you a head thing to cover lice from hopping off your head onto the head-mounted display, and they also wiped off with alcohol wipes the eye sockets every time in between every customer. I have a number of people come to my office and say, I want to build a virtual reality theme park, and I'm like, well, this is going to be really expensive because how many people can you get through, and what is it about the cleanliness and all. There is actually a report that I think Randy Pausch was instrumental in, Randy, God rest his soul, in how to keep these head-mounted displays clean in between customers. And Disney did a very big study of that. Let's talk about locomotion. What does locomotion look like? Really, the only nice solution that allows us to walk around in a 20-foot by 20-foot space right now is the HTC Vive. And that is with a giant cable being held by a second person. Or you could maybe put one of these in your living room. Okay, this is like an omnidirectional treadmill. It kind of keeps you in a circle, and you can walk around, and it's like walking on a block of ice. It's kind of cool. It probably costs a couple $1,000s to put this in there. But you can do that. And networking. Networking is really important whenever you build a virtual environment, because if you go back and you read all of the early virtual environment literature, a lot of the early virtual environment literature talks about virtual environments are built for a human-to-human interaction. And so human-to-human interaction means I'm on one machine, I've got a head-mounted display on, I can see my friend over there, Newton Lee, he's on another machine, and he's walking around in his environment, and we can kind of come up and have a communication and talk, despite the fact that he might be, somewhere in Burbank and I might be in downtown Los Angeles. And the second you start saying, I'm going to be in Los Angeles and I'm going to talk to you in Xi'an, China, then this becomes a networking big issue with all of the latency that is there in between the packet delays. And one of the things that you find in networking of games is you can't just build a game and add networking in at the end. Networking has to be designed in from the start, and networking has to be encrypted. It has to be security locked down, especially in virtual environment. I don't want to be in the virtual environment talking to my best friend about whatever we talk about and have the issue of someone else peeking in at us. All right, we've got to be able to restrict who comes in, hears what we have to say, or sees what we have to do in that virtual environment. So network interaction, there's a lot of stuff that the game industry knows how to do that has to be moved into the virtual environment industry. But also with the whole notion of we have to think about how do we make it latency free, because latency in virtual environments means you get motion sickness, all right? This is very hard. There's a lot of work to do on that. The other thing, let's talk about virtual reality film story. So if you go into Los Angeles and you go over to Hollywood and talk to film studios, their notion of virtual reality is 360 VR film, okay? And 360 VR film, which is I go and put a camera somewhere, it's taking video 360 degrees around me and audio and creating this really giant file, and we stitch it all together. And then when I am on my Samsung Gear VR and I'm out somewhere with the LTE network, I download this 5 gigabyte, 15-minute experience, and I bring it into my head-mounted display, and I look and watch at it. And one of the things is that people really have to talk about and understand well is what does story look like in a 360 VR film? We have 100 plus years of experience shooting motion pictures in 2D, which is, the director goes like this, you see them do that in movies all the time, or film, TV, and he says, oh, now that's what's going to be in frame, but now the director has to plan what's in the frame all the way around. And then the question becomes, what does it mean for me to be able to turn around and look behind? So if I'm in a regular film shoot, I turn around and look behind, I see the crew. All right, I see the crew, I see all the makeup people, I see all the folks who are off on the side. And if you were shooting something like Star Trek Voyager, you would realize that there isn't a real spaceship, that there's just a bunch of flats that are all kind of pushed together, and that if you kind of do a 360 pan, you'll break the illusion that you're in the spaceship. And you won't be happy at all. In fact, when you sit down at the controls and the Voyager series, you would see all of these buttons, and they were like jokes written in by the designers. And if you read the jokes when you're on camera, you crack up laughing. And so all of that stuff has to be taken into account. And so some of the issues are, what does it mean interaction-wise in a 360 VR film? So what that would mean, in the early days of VR, say in the mid-1980s or maybe even a little bit earlier, I think Michael Zyda did a lot of did a lot of demos with, disc recorders, so that you get to an intersection and you could choose go left, go straight, go right. And once you chose that, another piece of film would come in to show you going in that direction. We don't even have that in 360 VR. And the real question is pick a path adventure. And we know about pick a path adventure in games, it's very primitive. The real question becomes in 360 VR, something more exciting has to be happen. Otherwise, this is going to go up and not last a super amount of time. There's a lot of interesting R&D work here, for which we've made baby steps in technology, but no steps in authoring for such VR experiences. In fact, the real question that has been asked me multiple times, mostly by people in China, which is, can I help them create a research institute that focuses on virtual reality 360 story, and they will fund it. So I have, I think, at least 3 different organizations asking me to do that. In fact, one university in Xi'an, China, wanted to create an entire film department based on 360 VR film, because they think it's going to be that big a deal. And there's a lot of money in China. So, all right, things we really need to have to make virtual reality interesting, and I think this is the important part. And let's kind of walk through the list. And smaller, lighter head-mounted display. So what you're going to find is, right now when I put a Samsung Gear VR into my head, it's got this heavy head mount, heavy camera, heavy phone in it, and it's kind of, if I put it up there, and we do this experiment in the GamePipe laboratory all the time. My students build with it. They build with this. They build it for Google Cardboard, and they'll put an experience up. And probably the limit of most people right now is about 3 or 4 minutes in the virtual reality experience before they want to take the head-mount display off and say, okay, I know what it is. I haven't seen many people put it on and stay in a long time. The only time I've seen people stay in virtual reality a long time, by the way, is with the HTC Vive, and you saw with the big cables going out the back and a much heavier head-mounted display, what that looks like. That demo that Lu Ning was in, that I showed you the video of, that's a 12-minute experience by a company, I think it's called Interspace VR, and it's really, really cool. But it's a 12-minute experience, and they spent, I don't know, $300,000 or $400,000 authoring that experience. And the question becomes, okay, how do they make their money back in the next year, or the next 2 years, or the next 3 years? There's got to be some way they can make their money out of that. Right now, they got a great tech group that can build VR experiences. But what we really want is head-mount displays that weigh almost about the same as a pair of glasses. So this is kind of like going to a 3D movie now, which is, I go to a 3D movie, now I wear glasses. What that means is I have to put another pair of glasses on top of these glasses. All right, and it's sufficiently lightweight plastic that I'm okay with it for a movie. And usually I complain I don't want to see the 3D version, but all my friends want to go to that. They want to go see Doctor Strange in 3D. So I'm going to go when I go back home and put it on, and I'll put up with it. And actually I'll have a great experience because the story is so engrossing. That's what will happen. So we need to have something nearly no weight on the head. Electronics pack has to be somewhere else, not on the head. I have to laugh because in the mid-1990s, I think I visited North Carolina Chapel Hill, and they had the world's heaviest head-mounted display. It was 18 pounds. And you put it on, it's like, oh, my neck is breaking, I'm going to need like a neck brace after I get out of this thing. So people want lightweight. And we also need batteries that last all day, like cell phones. I think at GDC, I saw a demo by NVIDIA, and they had a Tegra chip in the back and a giant battery in the back, and they were proud. We get all the way to 50 minutes with our batteries. 50 minutes, okay. Good, if I had a cell phone that did 50 minutes, I would be like, time to get a new cell phone. All right, lightweight, non-intrusive tracking. No wires in the body, you can track the entire body. Fingers, lips, eyes. Here's fingers. So, I put this up here because this is a company that's raising a lot of money, Usense, and they can do fingers right now. And it's quite cool. So you can see this guy. Here's the little device. They'll sell you one as a development kit for $75, and you can tape it onto the back of your mobile phone. And so you can put that mobile phone to Gear VR, and you can look down at your fingers and give you full finger movement and hand that back to you so you can do stuff. And so what does that get you? This actually gets you to the mid-1980s in VR, because in 1980s in VR we had VPL with the data glove. And in the data glove, the first thing NASA did was they invented 27 different hand signs. It's like nobody can remember 27 different hand signs. In fact, that's what they discovered in the end, which was like grab something, let go of something, and point your fingers like this to go straight, and that was all anybody could remember. If you gave them 24 more symbols, hand things, they just had no clue. But anyway, these guys are going to figure that out, but they just got $5.5 million, and if you look at it, it's a science project. All right, science project, which I just had one of my business partners say, we have to have that in our system. No, you can't, because first of all, the major players who sell HMDs are going to be Oculus, it's going to be the Vive, and it's going to be maybe Samsung if they don't die, and probably Apple. And that's going to be the people who make this. And what has to happen is for USense to be super successful is those companies have to buy their technology and stick it in their phones or stick it in their devices. It's just there. You know, no one's going to, if you start building for this, you're going to have like three customers. Here's another one I saw recently. I think this is the work of Hal Lee at USC, and he's got a great thing, which is it's totally awesome. It's a face tracker, all right? And so I took these off of his website, and here's your head-mounted display. You've got a camera that's aiming at your lips, so that when you talk, he can animate a character's face. And it's kind of really cool because you can be Donald Trump, which is awesome. You can make Donald Trump say anything you want. Except for, you gotta have, but you could just record him, and that's what he will say anyway. But there's also, if you go in here, there's also cameras that are aimed at what your eyes are looking at where your eyes are, so that it can also animate the eyes. And so this is also a science project. You know, if this becomes lightweight enough and embedded in all the head-mounted displays, then developers can build for this. But this is exactly what you want. And I think this guy's gonna make this happen. He's gonna license this technology probably to everybody who makes the head-mounted display. Let's talk a little bit more about locomotion solutions. You know, we'd like to have a 20-foot by 20-foot space without wires. And what are we going to do with respect to locomotion and VR experience? And this is what the HTC Vive looks like now. And this is from their setup guide. All right, and it's great because what you'll notice, my favorite thing about this picture is this couch with chairs on it and lamps and empty boxes. They used to hold the Vive and all of its controllers. They're over there. And everybody who's got a VR lab, it kind of looks like this. In fact, for about 2 years, I rented a second apartment in the same building I lived in so I could have a Vive studio, just because I needed that. My funding was from Google. And we were funded by John Hankey in 2014 to build a client and an authoring tool for our prototype that was one of the prototypes looked at when they were building Pokemon Go. So it's kind of a cool thing. But anyway, you look at that and say, okay, I don't have a living room that big. Who has a living room that big and empty? Probably none of you. I don't either. But I have like three. At one time, I had 3 places to live at the same time, so it's kind of crazy. Now I just have 2. All right, so locomotion solutions. If you go out there online in Google and say, who has a locomotion solution? They all look the same as what we built in 1994, all right? And so we're not that much far along. And these things, you know, it's got like a thing to hold you up in case you slip and fall. That's a good thing. Get old, you fall. You don't want to fall too often. Then they kind of stop giving you things. You see this guy here. He's got a slippery infinite deck, which is, you know, treadmills that made of rollers that go in any direction you want. And then you've got these motion chairs. Now I've tried a couple of these motion chairs. These are fun. These are fun. You know, I tried one at a conference in Xi'an, and it was at the Silk Road Film Festival Virtual Reality Forum, and it was quite cool. So it was really fun. This was in September. So let's talk about speech recognition. And how many of you use speech recognition regularly? Like, okay, do you use Siri or Google? Google. So Google works. Siri is like, you know, I asked Siri, what's the capital of this country? And then we'll say, here's some web pages you could read. It's like, this is completely useless, right? And speech recognition that works now that I really, really like is I have the Amazon Echo. Actually, at my dining room table at home in Los Angeles, I have an Amazon Echo sitting next to an OK Google Home device. And so you can actually make them talk to each other, which is like really fun for about 5 minutes. And then they don't stop. You have to unplug the power. All right. So speech recognition is, I think, really important for the future of VR. And it has to be flawless and just work. And it has to work in a noisy environment. So one thing that's kind of nice about the Amazon Echo is it's got a whole set of microphones all the way around the top. And so you put on some, loud music, like some loud heavy metal music, and then you try and yell Alexa, Alexa, trying to get its attention so that it will stop playing the loud music so that you can do something else. You can kind of do that, but you want it to be flawless. You want that microphone in the virtual reality headset. You don't want it sticking out. You want it kind of like it's embedded in the device, right? So I don't have to worry about it. And we want speech as an interface rather than trying to remember 27 hand signs. And because I want to be able to say, you know, I'm going to open that door for me. I want to pick that thing up. I want to get me a new game. Yeah, that game. I want to say that. I want AI characters that I can talk to. If you're willing to get to virtual reality as an immersive experience, and you want to have characters that I can have a conversation with. Has anybody had that experience yet? Not too often. Okay, there's a company called Cognitive Code, and their website is cognitivecode.com. And the chief creative officer for Cognitive Code is Alex Mayberry. And Alex worked for me. He was my executive producer for America's Army 2.0, 2.2, 2.4. And where he is now, the first thing he showed me was an anime 13-year-old girl on a mobile device. And you can talk to her. And she remembers what you said and talks to you contextually and responds to you contextually. And she has a knowledge base of what a 13-year-old girl can be. And what we also learned in talking to them is, well, we could take all of the writings, say, of like Raymond Chandler, pump them in, and now I could talk to Raymond Chandler's detective, which I think is like, you know, if anybody remembers Raymond Chandler, he's like one of the most famous authors in the city of Los Angeles, wrote detective fiction in the 30s and 40s. And I'd love to be able to talk to him or his detective. And they have this technology, and it runs using the Google speech, on top of Google speech recognition. So they don't have to build the recognition, they just build the AI authoring tool on top, which I think these guys are awesome. So I want, it's got some work to go. I want it embedded in my VR device. So that gets me to the next stage. I want AI characters that have emotional models. So you think about this. To get there, I have to have a bunch of sensors. I'm always into sensors. And I want a hybrid EEG, which is tracking what is my brain doing? What does my brain understand my emotion? Can I determine my emotional state from the hybrid EEG device? And there's sufficiently enough interesting work in this area that the answer is yes, you can. And you can do things like, I can determine gross things like you're happy, you're sad, you're in the zone of the game, or you're lost in the game, or you just made a guess at the answer, and it was a guess and it was the right answer, but you guessed. And all of that type of stuff, we know how to get that from hybrid EEG devices that we build a big model using machine learning. And that is something that's kind of cool. We also want a camera aimed at the face. Again, we want Hao-Li's camera aimed at the face, embedded so it's not so ugly. And then we want it lightweight. We want some sensor and machine learning solutions for the emotional determination, of course. And when we do that, then we need AI characters that have an underlying emotional model. So if I'm going to talk to a pirate, okay, and the pirate has different goals and things he wants to do in life as opposed to what I want to do in life. And so if I'm going to have an experience with a pirate, and the pirate sees me getting angry about what the pirate's doing, the pirate should sense, oh, he's getting angry, and then try to make me more angry or make something else happen that is messing with me in an interesting and emotional and psychological way. And I think if we can, you know, not necessarily want to interact with pirates per se, but if we can get to that point, then we can get to very interesting, well-authored stories. And I think people will like that. And I think that's one of the places we have to go to. So we're going to have AI characters that we can interact with on an emotional level if we're going to get to well-authored interactive VR experiences. All right? We need high-speed mobile networks, and we have the right now we have the LTE networks, and if you live in just the right city, you can get really high speed. So where can you get high-speed networks? Not in the city of LA. The LTE network that AT&T has there sort of is there. Just try and load a web page. Sometimes you'll fall asleep while you're waiting for it to load. If you're in the city of Monterey, California, particularly at the gym where I go swimming, it's the best. So in Monterey, AT&T has a big thing called Language Line, which is translate and help people with language translation when during emergency circumstances. And so they put a massive infrastructure into Monterey. So you go and you'll get 30 megabits per second down and 20 megabits up wherever you're sitting in Monterey for the most part. I love that. I also see that when I'm in Beijing and I use the Google Fi telephone, which is awesome. So Beijing or Xi'an, I get 30 megabits down and 20 megabits up on my mobile device, and I use it as a hotspot. I don't even use that phone. So that means I have 3 phones. I have like two iPhone 7s, one for US, one for China, and then I have a Google Fi Pixel XL phone to be a hotspot. It's a little crazy. But we're going to 5G networks, and we're going to need 5G networks if 360 VR becomes big, because every 15 minutes it's 5 to 6 gigabytes that has to be downloaded. What that means is you have to be in a high-speed network to put it on your phone before you play it. Right? If you're going to stream it, you're not going to be happy for most LTE networks now. So maybe 5G is going to get us there. And I just put this picture up. I went out and I found this off the internet, and it basically says, okay, at 5G, we're going to get to 1 gigabit per second and higher, which is wonderful. The problem is really deployment. How fast will this get deployed? So I don't know if you remember when LTE got deployed. I was living in Venice Beach, California, and I had wonderful 4G, I had wonderful networking service to my mobile device, and they took and I lived right in the middle between 2 towers. And it turns out when they put LTE in, LTE doesn't transmit as far as the technology right before that. And so what happened is I ended up living in a dead space for mobile network. And I tried everything. There are no good solutions. You get one of those cell tower repeater things, which are a piece of junk that you hang up and it looks ugly and doesn't work. But when 5G gets deployed, and if it really works, it's going to be in places that really jump on the technology. It will be in China really quickly. It will be in Monterey really quickly. Los Angeles, maybe sometime after the Olympics in Los Angeles, it will be there. Maybe by the Olympics. That would be nice. I lived right near the Olympics. All right. Lighter, smaller, cheaper VR cameras. Okay, this is my favorite picture. Nokia Ozo, $60,000 VR camera, now pre-ordering. So I can make a gamble that this is the right thing and order it before it's there. In fact, what was it? The VR LA conference. If you went there, you could buy it. If you bought it on site with your credit card, you could get it for $45,000. I thought, oh, what a sweet deal. And I've been trying to get them to give me one. These cameras ought to cost like $600. And the cameras that are not science projects. So they have to operate in real time with real-time stitching. And this one does, evidently. They haven't got one yet. And they have to be connected to high-speed networks, which means, when I'm out in the real world, the 5G network has to be there so that I can stream live from Venice Beach to whoever wants to watch Venice Beach live in 360 VR. And people like that. I like Venice Beach. It's kind of fun on a Saturday or Sunday. It's very exciting. And so who's working on cameras? Everybody. It's, actually the slide I really wanted to make, which I failed to do, is how many people are also making VR headsets besides Oculus and besides HTC and Samsung and Apple. There's not, Google, right? Google Daydream. I got that on orders. It should be there like this next week. But if you go in the 360 camera space, everybody is doing this, and they're all like $15,000, $60,000. They're ridiculously expensive. And yes, you can get everyone says, oh, I can get the Theta camera. Theta's fun. It's a party trick, It's not there yet. And the real thing is, the format for each of these is different. All right, so there's starting to be some standardization in this field. There's, I think, just 2 formats. There's like one that plays on Apple and everything, and then there's one that Google has that plays on Google and not Apple. So that's sort of the classic problem. There's probably one that Microsoft has that hasn't come out and will fail. All right, I'm probably running out of time. Okay, augmented reality. Augmented reality is going to be a bigger thing than VR, as people can see where they're going. They don't trip over things, and they can see their friends. And there's just a lot of applications that you can do with it. All the medical and educational and engineering and manufacturing jobs that will use augmented reality is huge. So where's our successes in augmented reality right now? Pokemon Go, and it's, Pokemon Go is cool. They got 500 million players like in a week. That's amazing. And they make several $1 million a day in money from Pokemon Go. So Niantic Labs was kicked out the door from Google. Everybody who stayed in Niantic Labs after it was kicked out the door from Google, I think, took a pay cut by half. In fact, I knew somebody who didn't go with Niantic and decided to stay back at Google because he liked $200,000 a year. They're probably getting their salaries pushed up now because their success. And they keep adding and doing content. We have 2 of the designers of Pokemon Go teaching in my program. And one of them is a former student of mine. So, all right, here we go, Microsoft HoloLens development kit. Okay, this is why Microsoft is failing in almost everything nowadays. So developers are usually in the VR space are really small companies that have almost no money, and the developer kit is $3,000. I mean, HTC was kind of funny. When it first came out, they would give you one for free if you were a developer, but they had exactly 20 headsets to give out to people because they really didn't have manufacturing up and running. But I can go buy this for $3,000. Ridiculous. That price is crazy, all right? And in fact, I went to VR LA and I put one of these on, and I thought it was not a very good system. At least the demo I saw wasn't very good. But when you go off and you look at Microsoft webpage, they will show demos like this, which looks exactly like the Magic Leap demos, all right? And so if they can put out stuff like this, and I have yet to see it, that's fantastic, but they're not going to get a whole lot of developers at $3,000. They got to put this about $700 or give it to developers for free. Magic Leap. So Magic Leap has done a couple of things. I have like I said, my son works there, and I've talked to a couple of people who've seen the live demo, and they have all signed NDAs, and they can't really say anything about it. All they can say is that it's absolutely fantastic. It's going to be the greatest thing since sliced bread when it comes out. It's going to be lightweight thing. It's going to look like that. That's from their patent, and the other pictures from their patent as well. And it's going to be awesome. So let's assume they come out in the next 18 months. They kind of have to come out because Microsoft's going to start putting out their system in consumer grade, I think in the next year. They'll do it next year. And recent article was Magic Leap says developer milestones met. Development milestones met. Patent shows sleek form factor. And so they're just about to get there, and we'll believe it when we see it. Anyway, they have some major technological marvels to finish. And you've seen all of these demos. I think if you haven't seen this demo live on the internet, that looks really cool. If they can really do that, then they win. All right, they win VR and AR. Because if I have AR, I can turn it into VR just by painting all the pixels, right? And I can also make it so that you can see the world in that trip. And they're also focusing on lightweight, which is even more spectacular. And again, one of their technological challenges has to be power. How do we get power to here? It's a light field projection directly into the retina of the eye. One of their chief scientists is an MD ophthalmologist who has a company called Visario. I'm an advisor to his company, so never tells me a thing. So there are multiple components to the VR AR space. There's R&D. You get to try out new things not available, or things that are too expensive for the consumer market, or things that are duct taped together. And I think this is great. There's no government money to do this. This is all happening in the startup space, which is nice. But what it does mean is there's no archival publication. So if the startup crashes and burns, the only thing left is the patents that get sold at the patent sale, and all of the technology is not necessarily disclosed in the patent, all right? So that's a very critical thing to think about. Advanced prototypes. Integration of new technology into a test system to see how it works and performs, and then build and develop deliverable real systems that have real customers. And I think I already said this, but 2016 and 17 are VR and AR developer years. And 2018 and beyond is when we see a real consumer market. So if you do a startup now and say, I'm going to build a VR studio now, this is a good time, because by the time you get something ready to go by the start of, or the end of 2017, early 2018, then you could be exactly the sweet space. And I think that people who started 18 months ago will be broke by then because they haven't sold anything, all right? Now what else is going to happen? Epilogue, virtual reality wars. The other thing I do is I work in patent litigation as an expert witness. I've worked for 32 law firms on 32 different lawsuits. And I've always worked for large game companies or computing companies, and as those are the people who hire my students. Now, we're coming to a very large virtual reality patent war. So in the mid-1980s to the mid-1990s, there were a number of companies trying to make a living in virtual reality technology, and all of them have crashed and burned. And all of those patents have been acquired by non-practicing entities. And so as soon as this becomes a billion-dollar profitable business, there will be massive patent wars. In fact, I'm already on one. So this is going to be a big deal, and it's going to be sort of the how do we make this not kill the business. I'm almost done. Anyway, questions? That's where I am. If you're on WeChat, that's how you find me. And Zyda at usc.edu is how you find me. That is the end of my talk.
Yeah.